The National Electrical Code, or NEC, Article 250.118 subsection 10 states that conduits containing parallel conductors of a motor circuit operating at over 150 volts to ground must have an equipment grounding conductor connected at both ends. NEC Article 250.118 subsection 8 states that flexible conduit must meet certain length and protection requirements when used with an equipment grounding conductor. For conduit A, compliance with the NEC is met as the equipment grounding conductor is connected at both ends and the motor circuit operates over 150 volts to ground. The greenfield and flex conduit sections meet the length and protection requirements for flex conduit with an equipment grounding conductor. For conduit B, an equipment grounding conductor is not required by the NEC as the circuit voltage is 120 volts and the load does not exceed 1.2 amps. However, it is recommended to install an equipment grounding conductor in conduit B for additional protection against ground faults. For conduit C, an equipment grounding conductor is not required by the NEC as the circuit voltage is less than 30 volts and the current is less than 10 milliamps. However, it is recommended to bond the conduit to the grounding system at the controller end for electromagnetic compatibility, or EMC, purposes. The proximity of conduit A and conduit C may introduce electromagnetic interference, or EMI, into the low-voltage signal cables in conduit C. To mitigate this, consider installing conduit A and conduit C in separate pathways or using metal conduit for conduit C. Ensure that all conduit connections are properly tightened and the grounding continuity is verified throughout the entire system. Having an equipment grounding conductor in conduit A provides a path for ground fault currents to safely return to the source, reducing the risk of shock and damage to equipment. Adding an equipment grounding conductor in conduit B, even though it is recommended and not required by the NEC, provides a similar path for ground faults to enhance safety and reduce potential damage. Bonding conduit C reduces electromagnetic compatibility by providing a low impedance path for common mode currents and electrostatic discharge, minimizing the potential for interference with low voltage signal cables. In summary, the National Electrical Code provides specific guidelines regarding the use of equipment grounding conductors in various conduit systems. These guidelines are designed to ensure electrical safety and minimize the risk of equipment damage. Firstly, it is important to understand the voltage and current levels within each circuit. Secondly, it is essential to consider the type of conduit being used, including flexible metal conduit and non-metallic options. Thirdly, special attention should be paid to motor circuits operating at higher voltages, as these often require equipment grounding conductors to be installed. For motor circuits operating above 150 volts to ground, the NEC mandates the presence of an equipment grounding conductor connected at both ends of the conduit. This requirement helps to provide a low impedance path for fault currents, ensuring that protective devices such as circuit breakers or fuses can quickly and effectively clear any ground faults. When flexible metal conduit is used, specific length and protection requirements must be met to comply with the NEC. These requirements are intended to maintain the integrity of the grounding path and prevent damage to the flexible conduit itself. In situations where the circuit voltage is relatively low, such as 120 volts, and the current draw is minimal, the NEC may not require an equipment grounding conductor. However, even in these cases, it is often recommended to install an equipment grounding conductor as an added layer of protection against ground faults. The equipment grounding conductor provides a path for fault currents to flow back to the source, reducing the risk of electric shock and minimizing the potential for equipment damage. For circuits operating at very low voltages, such as those found in signal cables, the NEC typically does not require an equipment grounding conductor. However, it is still important to address electromagnetic compatibility concerns by bonding the conduit to the grounding system at the controller end. This bonding helps to minimize electromagnetic interference and prevent unwanted signals from being introduced into the low-voltage signal cables. When installing multiple conduits in close proximity to one another, it is crucial to consider the potential for electromagnetic interference between the different circuits. For example, if a conduit carrying high-voltage motor conductors is placed next to a conduit containing sensitive signal cables, the electromagnetic fields generated by the motor conductors can induce noise and interference in the signal cables. To mitigate this risk, it may be necessary to separate the conduits physically or use shielded conduit to reduce electromagnetic coupling. Regardless of whether an equipment grounding conductor is required by the NEC, it is always important to ensure that all conduit connections are properly tightened and that the grounding continuity is verified throughout the entire system. This verification helps to ensure that the grounding path is continuous and effective, providing a reliable means of protecting against ground faults. The purpose of an equipment grounding conductor is to provide a low impedance path for fault currents to flow back to the source. This low impedance path helps to ensure that protective devices such as circuit breakers or fuses can quickly and effectively clear any ground faults, minimizing the risk of electric shock and preventing damage to equipment. The equipment grounding conductor also helps to equalize the voltage potential between different metal parts of the electrical system, reducing the risk of stray currents and further enhancing safety. In addition to the NEC requirements, there are several other factors to consider when designing and installing conduit systems. These factors include the type of environment in which the conduit will be installed, the potential for physical damage, and the presence of corrosive substances. In harsh environments, it may be necessary to use special types of conduit that are designed to withstand the elements and protect the electrical conductors inside. For example, rigid metal conduit is often used in outdoor applications where the conduit may be exposed to rain, snow, and sunlight. In areas where there is a risk of physical damage, such as from vehicles or machinery, it may be necessary to use heavy-duty conduit or to protect the conduit with barriers or guards. In corrosive environments, such as chemical plants or coastal areas, it is important to use conduit materials that are resistant to corrosion. For example, PVC conduit is often used in these types of applications because it is highly resistant to chemicals and salt water. When selecting conduit fittings, it is important to choose fittings that are compatible with the type of conduit being used and that are properly rated for the application. Conduit fittings are used to connect sections of conduit together and to provide a means of terminating the conduit at electrical boxes or enclosures. It is important to ensure that the fittings are properly tightened and that they provide a good electrical connection to the conduit. Grounding bushings are used to provide a grounding connection between the conduit and the electrical equipment. Grounding bushings are typically installed at the point where the conduit enters an electrical box or enclosure. They provide a low impedance path for fault currents to flow back to the source, helping to protect against electric shock and prevent damage to equipment. When installing conduit systems, it is important to follow all applicable codes and standards. These codes and standards are designed to ensure that the electrical system is installed safely and that it meets the requirements of the NEC. It is also important to use qualified electricians who are familiar with the NEC and who have the necessary skills and experience to install conduit systems properly. Regular inspection and maintenance of conduit systems are essential to ensure that they continue to operate safely and effectively. Conduit systems should be inspected periodically for signs of damage or corrosion. Any damaged or corroded conduit should be repaired or replaced promptly. Grounding connections should also be inspected to ensure that they are still tight and that they provide a good electrical connection. The NEC provides a comprehensive set of guidelines for the installation of electrical systems, including conduit systems. These guidelines are designed to ensure that electrical systems are installed safely and that they meet the requirements of the NEC. By following these guidelines and using qualified electricians, it is possible to install conduit systems that will provide reliable and safe electrical service for many years to come. To summarize, consider these key points. 1. Determine if the voltage to ground exceeds 150 volts in the conduit. 2. Determine if you are using any flexible conduit and what length is being used. 3. Consider the current and voltage of the circuits being protected. 4. Determine the proximity of other conduits for electromagnetic interference considerations.